Hi, my name is Matt, and this is Master Blaster 4000. Just look how bright it is. Hi guys, we're gonna explore a world of LEDs and a matrix a little bit more, and I'll show you how to build one and what to pay attention to. So this is for beginners, so if you're new to LEDs and you want to learn how to drive LED strips, you're gonna like this video. First of all, shout out to my sponsors. Banggood has sponsored this project and this series. They provided all of these glorious LEDs, and I'm gonna link all the items that I needed for this build in the video description and also in my article as well. So, first of all, we're going to start with building the matrix. After gluing up the LED strips to the wooden board, one line facing left, then one line facing right, I proceed with soldering the cable that will carry the signal. So there were 2 loops in one side and 3 loops in the other side. I've repeated the same with the power and with the ground. I knew there would be problems with the voltage, however I wanted to see how far I can actually power the LED strip before I'm gonna see distortions in colors. Once everything has been done and I had 5 strips, I could actually test if it's working correctly. Then I proceed adding another 5 lines, totaling 410, and I could test it with a potentiometer. As you can see, as the signal goes further and further, the LEDs are turning into orange and then red. This means we have a power problem, and I'm essentially able to power up about 40 LEDs altogether before I run out of current and the LEDs are starting to get dimmer and dimmer. This means I needed a new setup in terms of power delivery for an entire 10 strips, and this is what I've used. You can also see it in the description of this video. The power delivery has changed as well. I'm using the switching power supply, which provides some power for the driver. So entire delivery of power has been changed. I've linked 2 cables to the switching power supply, and they connect from both ends of the strip, and each line is interconnected on both ends as well, to minimize the voltage drop. That way, on each line the voltage should be constant, and that's why I'm gonna get such a bright effect, as you could see it in the showcase just before this video. In addition to that, I've got 5 volts and ground connected to the breadboard. I need ground to be connected with ESP and with the potentiometer as well. The same power rail powers the chip, and here's the final effect. You can see the lights are very bright and they remain consistent regardless of how many LEDs I turn on. There's 410 LEDs at the maximum brightness at 253. Works great. Now this is the second iteration. I fixed the power problem, so the power problem isn't an issue anymore, and this is why the LEDs are so bright. Now for testing, I've used white light, because white light requires all 3 channels, the red, green and blue, to be used, and that's why it uses the most power from all the colors. I've set the brightness to 253, which is the maximum brightness possible with this, and it's mighty awesome. It's actually, you can't see it on the camera, but this panel is brighter than all the lights that I've got in here, and I've got like 3 LED bulbs up, and the light in here, there's lights from the computers and some extra LEDs in here, and this panel is still brighter than this, and I can provide more light than all of these together. Before I actually could use my lights, I needed to calibrate it, because Fast LED supports color names, so if I type in red, it's supposed to display red, but that wasn't the case. So I've uploaded the script from the examples, and all you have to do is just find your LED type, uncomment the code, and it will display a few colors telling you how to configure your script. So basically it's going to be 6 colors in a certain pattern, and based on that pattern you need to change RGB channels into correct order. So my pattern was correct, so everything was alright. All I needed to do is just to copy the snippet, which is RGB order from here, and use that into my code during the setup, so the channels were assigned correctly. So let's look through the potentiometer script I've used. Modify your script. Just look for the setup line and modify the RGB channels from here to the correct order. Everything's going to work great. So include the library, set 410 pins, LEDs on pin 5, brightness to max. Then pin 2 is potentiometer. I'm setting the value to 0. Then I create an array in memory. It's going to store all the LEDs, so 410 LEDs corresponding with numbers. And in the setup, I'm just using the name of the LEDs, the data pin, the order of channels, and my brightness. And I'm looping through, reading the value of the potentiometer, converting this value from the voltage into a map between 0 and 4095. So that's what it's going to do, and basically clear all the LEDs. And each time I turn, I want to basically add 1. So when the value increases, I'm just gonna go through for loop and add, pick another number from the that array and write the color white, and that's it. So if you follow these instructions, you should have Matrix fully operational and quite bright. So in the next video, we're gonna focus on how to actually code the lights in detail, and how to create either channels or how to use a single channel to control multiple lines. For now, thanks so much for watching, guys, and yeah, follow me on social media, subscribe to my YouTube channel, and I will see you in the next video. Take care, bye.